Hi everybody! Today is a very short tutorial on how to freeze certain atoms in your simulation. Here my example is a chlorine anion surrounded by water molecules, but because it's taken from a PDB, there are no hydrogens. So for example, um, let's say that I want to keep the water molecules where they are, so the oxygens should be frozen, but I want to optimize the positions of the hydrogens, for example. First, let me add the hydrogens. You can go into this build, add hydrogens tool, and then magically your hydrogens will appear. So as you can see, I have one too much over here, and I'm gonna go ahead and erase it because I want the chlorine to stay an anion. All right. So now that I have my hydrogens here, as you can see, there have been all added exactly in the same way. Clearly, this is not optimized. So I'm going to go first into build Cartesian editor, and I will sort my atoms by element. Okay, well, it's already been done before, but anyway. So now I have all my oxygens together and followed by hydrogens all the way to the end, and chlorine is the first one. Why do I do that? Is because I want an easy way to compact an easy way to get all my oxygens labeled together, right? So now my oxygens are number 2 to number 11. All right. I can go into extensions, Gaussian, create my Gaussian input, um, and you have to modify it a little bit. So here I have charge -1, multiplicity 1. Um, I'm doing a Hartree-Fock calculation using a 631 GD basis set. Um, Technically, you should add some plus here, but okay, because you have an ion. But let's keep it simple. So if you want to freeze some atoms, you need to use this read freeze keyword, which indicates to the program that certain atoms should not be moved. Now, if you scroll all the way to the end, after the last Cartesian coordinate, the last atom, you have to skip a line, and you add this line over here, no atoms, space, atoms equals to the labels of the atoms corresponding to the atoms that you want to freeze. For me, it's atoms 2 to 11, so there you have it. All right. And then you run your normal calculation. Okay, and the output of that is right here. So as we expect, the hydrogens of the water molecules are now facing the chlorine and ion, right, to screen the negative charge. And the only problem here, it's a little bit hard to see because Avogadro doesn't do the superimposition of the molecules, but you could check technically with your Cartesian coordinates, right, to see if the oxygens moved or did not. And I checked, they didn't. so, um, so there you go. If you have some molecules that you would like to freeze, that's a very simple way of doing your half frozen simulation. That's it.